balance redox. In this video, we are going to look at how to balance redox equations using the half reaction method in acidic medium. Ready? Let's begin. Here's the equation that we are going to balance. SO3 2- react with MnO4- to produce SO3 2- and manganese 2+. Now, balancing a redox equation is a little bit more challenging than just balance a regular chemical equation, because a redox equation we have to balance not only the individual atoms but also the charges. So here a step-by-step method we use to guide us through the process. Okay, first step is we separate the equation into two half equations, which is oxidation and reduction equation. Two half equations separate by referring to the most similar species, for example S to S and Mn to Mn. To know which elements are getting oxidized and which are getting reduced, we can figure this out by looking at changes in oxidation numbers for this polyatomic ion. For example, for manganese and sulfur, there is no specific oxidation number. Okay, so we will have to figure it out based on number of oxygen atom in polyatomic ion. Usually, when number of oxygen atom increase, the reaction undergoes oxidation reaction. Meanwhile, if number of oxidation decrease, the reaction undergo reduction reaction. So, SO3 2- produce SO4 2- is oxidation half reaction, and MnO4- produce Mn2+ is reduction half reaction. Okay, next. We are going to balance each one of these equations separately. Okay, so we start with element, balance element. After we separate the equation into two, the next step is balance the element. Okay, for oxidation reaction, we have sulfur on the left side, one sulfur on the left side, and one sulfur on the right side. Okay, so the sulfur is balanced between left and right. So next is Mn. On the left side, we have 1 Mn, and on the right side, we have 1 Mn. So element sulfur and manganese are balanced in both sides. Now, we are going to balance the oxygen. Okay, oxygen, look at SO3 2-. We have 3 oxygen, and in SO4-, we have 4 oxygen. Okay, and in MnO4- produce Mn2+, MnO4- we have 1 oxygen, and Mn2+, we have no oxygen. To balance the oxygen, okay, we are going to add H2O. Okay, so as the left side, we have 3 oxygen in SO3 2-. On the right side, we have 4 oxygen in SO4 2-. So to balance the oxygen, we add H2O. Okay, so 1 mole H2O, we have 1 oxygen atom in H2O. So 1 oxygen atom plus 3 oxygen atom in SO3 2- equal to 4 oxygen atom. So we have balanced oxygen atom in oxidation equation. Okay, now let's balance reduction reaction. Okay, MnO4 minus. So in MnO4 minus, we have 4 oxygen atom, and Mn2 plus, we don't have oxygen atom. So we have 2 plus 4H2O to get 4 oxygen. We have balanced oxygen, we have balanced sulfur, we have balanced manganese. Okay, now I will introduce another element into chemical equation because now I have 2 hydrogen on H2O added and I don't have any hydrogen on the opposite side. Okay, so in order to balance out the hydrogens, I added by introducing oxygen atom already balanced by adding H2O. Okay, but I introduce another element to chemical equation because now I have hydrogen on side of H2O added and I don't have any hydrogen on the opposite side. Okay, so in order to balance out the hydrogens, okay, I added by introducing H. Going to add H plus to the other side. I got 2 hydrogens on the left side, so I am going to add 2H plus on the right hand side. So I have 2 hydrogen on both sides of equation. So now my sulfur, oxygen and hydrogen are all balanced. Okay, repeat these steps for reduction half equation by balance the hydrogen atom by adding H plus ion to the opposite side of equation. Make sure manganese, hydrogen and oxygen are all look at second equation. MnO4 minus produce Mn2 plus H2O. So on the right side, we have 4 times 2. That means we have 8 hydrogen. So to balance 8 hydrogen, we have to add 8H plus. Now we already separate the equation into 2 oxidation and reduction equation. We already balanced the element except hydrogen and oxygen, and then we already balanced the oxygen with adding H2O. Next, we already balance H by adding H plus. So now we have to balance the charge by adding electron. The concept of balancing charges in an equation might be new to you. So let's go slowly and look very carefully. Okay. In oxidation reaction, we have SO3 2 minus plus H2O produce SO4 2 minus plus 2H plus. So SO3 2 minus, the charge is negative 2. Net charge of SO3 2 minus is negative 2. As for H2O, the charge is equal to 0. Okay, so total charge on the left side is equal to negative 2. So now let's calculate the charge on the right side. SO4 2 minus, so negative 2. The charge is negative 2. And for 2H plus, the charge is positive 2. So total net charge on the right side is equal to 0. In order to balance this equation, okay, on the left side we have negative 2 charge and on the right side we have 0 charge. So to balance the equation, we have to add electron to right side. So how many electrons should we add? we should add 2 electrons. If we add 2 electrons, that means it equal to negative 2. So, on the left side, we have a total charge on the left side is negative 2. So, similar to right side, the total charge is equal to negative 2 after adding 2 electrons. Next is MnO4 minus plus 8H plus produce Mn2 plus 4H2O. MnO4 minus, the charge is negative 1, 8H plus positive 8. So the total charge on the left side is equal to positive 7. Okay. On the right side, Mn2 plus, the charge is positive 2 and H2O is neutral, so 0 for H2O and total charge on the right side is equal to 2. So now we have to balance the charge between left side and right side by adding electron. Okay, so electron have negative charge. Okay, so now we are going to balance the charge by adding 5 electron on the left side. Next is to balance the electron in each equation. The electron on each half equation must be equal. If they are not equal, they must be multiplied by appropriate integer, usually the lowest common multiple. Okay, so we have balanced both left and right. Here, for oxidation half equation, I have 2 electrons on left side and 5 electrons for reduction. Here, for oxidation equation, I have 2 electrons and for reduction equation, I have 5 electrons. So, I have to multiply by 5 and 2 respectively. The half equation are added together, cancelling out the electron to form one balanced equation. Common terms should also be cancelled out. Okay, so in this case, we have 5SO3 2 minus plus 5H2O produce 5SO4 2 minus plus 10H plus 10 electron. And another equation, we have 10 electron plus 2 MnO4 minus plus 16H plus produce 2 Mn2 plus 8H2O. Okay, so we are going to cancel out electron. Okay, similar common terms. Okay, we have electron. We are going to cancel out electron. And then H2O, we have both H2O on left and right side. And then we have hydrogen ion. Okay, so we have to cancel out electron, cancel out H2O, and cancel out H plus. Cancel out electron. And then here we have 5H2O. On the right side, we have 8H2O. So 8H2O minus 5H2O. Okay, so here on the left side, we have 16H2O. On the right side, we have 16H plus minus 10H plus. Okay, so our equation now is, final equation will be 5. We are going to combine both oxidation and reduction equation. So, combine on the left side first. Okay, so here we have 5SO3 2 minus plus MnO4 minus plus, okay, we have remaining 6 hydrogen ion, so plus 6H plus produce, okay, and then added compound we have on the right side. Okay, so we have 2Mn2 plus 5SO4 2 minus plus 3H2O. So now we have full equation. 5SO3 2 minus plus 2MnO4 minus plus 6H plus produce 2Mn2 plus 5SO4 2 minus plus 3H2O. To double check this equation, you can calculate each element and charges either they are same or not, both right and left side. Okay, so that's all for balanced redox in acidic medium. Okay, if the equation is in a basic medium, there is one more step, which is the equation should be added with appropriate number of hydroxide ion OH minus to the both side, okay, on the right side and on the left side, according to how many H plus are remain in the equation. As conclusion, remember this acronym SEOHCA. I repeat, okay, SEOHCA. Okay, S for separate equation into two, which are oxidation and reduction equation. E for balanced element except oxygen and hydrogen. So balance, usually we are going to balance metal followed by non-metal except hydrogen and oxygen. O for balanced oxygen with H2O. Next is H, balanced hydrogen with hydrogen ion or H plus. C, balanced charge with electron. Okay, and then the last one is A. A is for add both electron. Okay, in the first step, as separate equation into two. So in the last step, we are going to add. Okay, we are going to combine both equation, oxidation and reduction equation, to form one equation as we begin. Thank you.